All right, so today's flight is San Francisco to Kalispell, Montana, also known as Glacier Park International. Um, and uh-oh. That was weird. It just tried to boot me. Anyways. Okay. So, once again, we start out with our route briefing guide. First thing that we're going to do is we need to find our ETA so that we know whether or not we're legal, because we got to figure out the very first thing we need to figure out with this flight plan is, are we legal or are we not? We need to figure out our ETA, and then with our ETA we can figure out our legality. So right now our ETD, estimated time of departure, is 09:45. Okay. So the first thing we do to figure out our ETA, we need to go to Skyvector and we just put in here our departure airport is KSFO and our destination is KGPI. Okay, we have a direct distance there. So what I do is I multiply the distance by 1.1, and that gives me a 10% padding to my distance. So I do 733.4 times 1.1, times 1.1, that gives me a distance of 806.7 miles. Okay. What I do with that to convert it to time is I divide that by an average speed of 400 knots. Okay, this speed is just an average that we always use when we're finding an estimated time en route. Okay, so 400 knots gives me almost 2 hours exactly. We're gonna go 2 hours and then that 0.1, so 2.1 hours. Okay, that's our ETE for this flight. This isn't accounting for winds. It's not accounting for anything but just a rough estimate. Okay. Now I can take that 2 hours or 2.1 hours, and I can add that to my estimated time en route, and that gives me what? 11 hour or so 0.1 converts to 6 minutes. So 2.1 is 2 hours and 6 minutes.
That was actually 2.01.
I know, but I just rounded it up to 2.1 for fun reasons. I didn't want a nice even number. I want to show you guys using a little variance there. So 2 hours and 6 minutes. Add that to my 9:45. That gives me 11:45, 11:51 is my estimated time of arrival. So 11:51Z is my ETA. So With my ETA, I can now go look at my weather and determine legal to go. So I'm going to go to my destination tab. So we go to GPI right here in our route briefing guide, go down to the TAF, and my ETA falls into that first line. Okay. Variable at 3 knots, greater than 6 miles visibility, and skies clear. I'm legal to go. Okay. Now I apply the 1, 2, 3 rule to that. I go look at my ETA window. So my ETA window is 10:51 to 12:51. All of it falls in that first line there. Okay. I know that it meets the 1, 2, 3 rule of 1 hour before, 1 hour after the ETA. I have at least 2,000 foot ceilings and 3 miles or greater visibility. So we don't require an alternate. Just to verify that everything's kosher here, I look here at my NOTAMs and I go, oh, GPI, the nav. Okay, so the SAK NDB is out of service. I'm going to quickly look at my Jeppesen chart here. And see if my approach into the airport requires that NDB. Okay. So the SAC NDB right there. It's not part of my missed approach procedure, and it's not my it's not my approach at all. So I know that I'm good to go. It's used as a reference point, but it's not technically part of the approach. So we're good to go. Okay, FDC NOTAMs says some RNAV. We got RNAV GPS, ILS or localizer runway 2. Disregard no night landing runway 12 and 30 not authorized. Okay, we're not landing at night, so we're good to go. Okay, I've determined my legal to go. I've also determined that I don't require an alternate. So what I do next, and see that only took 3-4 minutes to determine that, right? So now in Skyvector, I can go in and I can look at I'm gonna actually plan my route here. So this is the route that I'm actually going to use. So I can zoom in here, and we're gonna go to the San Francisco charts, and we're gonna pick out a SID and a star first. So San Francisco. So for my SID, because I'm departing San Francisco, come down here to SIDs, and I find a SID that puts me out to the north. Okay, I'm in my SID section. All right, here's one that kind of puts me out to the north, but stays on the coast. So I don't know that I like that one. Let's see if there's something better. This one takes me down the coast to the south. Don't like those. All right, so that's all my SIDs. So there's the San Francisco 4 departure, or we can use the Mullen 8. Departure. Since this is kicking me out onto the coastline, I think I'm going to go with this vector SID. So I'm going to pick Red Bluff or Sacramento as my transition point. So I come in here to into my Skyvector, and I do SFO 4, and now I can zoom in to find out where Sacramento VOR. So here's Sacramento VOR right here. There's Sacramento. Let's find Red Bluff. Red Bluff puts me right here. I think I like Red Bluff more out of the two because Red Bluff kind of spits me out parallel to my where I'll probably be flying. Kind of sends me in the right direction. Okay. So all I do is put in Red Bluff, hit enter. Okay. And that plans my departure route. There you go. Take off from San Francisco on the San Francisco 4 departure. Transition point is Red Bluff VOR. Now we just do the same thing for Kalispell, Montana. Okay. So come into my jet charts, go to Kalispell. Look for a star. Oh, no stars in Kalispell. So whenever we have a station that doesn't have an arrival or departure route, we always navigate to the nearest VOR and then from that VOR fly direct to the airport. Or from the airport, if it's a departure, say we were leaving Kalispell, we would leave Kalispell, fly direct to the nearest VOR, and then fly out on a jet route or Victor route. Does that make sense? Okay.
Is it very common for there not to be?
Yeah, I mean, for the not major airports, yeah. So so what I can do now with Skyvector, which is really nice, is I can drag and drop onto my route. So I just find the VORs that follow a jet route or a Victor route and just drag it over, plan the VOR. Do that again here. Drag the line over to the VOR that I want to use, let go, plan that VOR. There's Kalispell, Montana right there. Once again, drag it over, let it go, drop, drag it over to this VOR, let it go and drop. Okay, is that the closest VOR to Kalispell? Negative. We can see Kalispell VOR right there. It's just on our load chart. There's nothing wrong with using your load charts. Okay. If you want to fly an even more direct route, we can unplan this one. Just take it out. Oops, hold on. And from here, let's go back to our high chart real quick. Back to the low. Oh. No, there's not a Victor route that will connect us in there. So let's plan right there. Let's see if there's something that goes from this VOR a little more direct though. To Kalispell. So there's actually Victor 448 here that goes direct to Kalispell. We can use that. Puts us on Victor 448. Okay, that way we don't have to come down here to Mullen Pass and then up to Kalispell. Okay. So we've got our route in. This gives us a distance of 807 miles. It's pretty close to what we estimated, right? With our pattern. So 800.7. That's pretty much 2 hours on the nose, right? For an estimated fuel burn. We're just going to use the 2 hours and 6 minutes still, so the 2.1. Okay. So now that I have my route, there's a couple things that we can do here. But I think what we're going to do is we're going to go into our weight and balance chart now, and we're going to start working on this packet here. Okay, so let's go into our weight and balance, and we're going to fill this out. All right, number of adults. Let's see here. Got 57 adults.
57 and 5 kids.
And 5 kids. That gives us a grand total of 62. All right. So 57 adults in our summer weights equals 10,830. Can you guys see it better on your sheets? I can't see.
Yeah, that's right.
Okay. 10,830. And for the kids, we just take this 82 pounds here and multiply it by 5.
410.
410 pounds. Okay. Add those two together. Gives us 11,240. 11,240 pounds. Okay, now we have our payload or our passenger load. Okay, so I can plug it in here. Okay. Now we need to figure out what our bow weight is. So we come over here, 754 Sierra Kilo.
448.43.
What was that?
44,843.
Okay. And what was the index?
71.5. 6.
71.5 or 6?
6. Oh, no. Sorry. 71.6.
Okay. So 71.6. Our passenger index we need to go and figure out. Okay, so we start in the back. I like to start in the back of the plane. We can have a total of 70 passengers, so we go 70 minus 62. What does that give us? 8. take that 8 from the front. So that gives us 4 passengers in the very front. First class, baby. And then full loads in each one after. Okay. That gives us a total of 62 passengers. Easy? Easy peasy? Okay. Now we got.
A is 6.4.
Now we just to show you guys on the video, this is where we're pulling this. So we just go to 4 in zone A, 6.4. So 6.4, and then just continue down.
13.9. 8.5.
Oops.
3.1.
8.5. 3.1.
2.8. 6.8.
Okay. Come down here. Total of 6.4, 13.9, 8.5, and 3.1.
31.9.
31.9. Okay. And this is 9.6. Oops. So we just bring our 9.6 below the 31.9.
22.3.
That gives us 22.3. Remember that these ones are negative. Okay. So our index comes out to be a negative 22.3. Okay. Well, let's slide it over in the negative slot. Okay. Our cargo that we have is 87 bags. So we come over here to our average bag weights,
2610.
2610. And then the 2610 cargo aft is 17.3. Okay. No forward observer, no forward cargo. So we just take these numbers and bring them down to here. Actually, that's not going to get me where I want. All right. Okay, so 71.6 plus 17.3 equals 88.9. Okay. Just bring down that negative 22.3. Okay, and 88.9 minus 22.3 gives me 66.6. Oh, this is bad.
Great one.
Power of Christ compels you. Okay, and the total of our zero fuel weight comes to, just add those numbers up,
58,693.
58,693. Okay. So now we need to figure out the fuel really quick. So I did the 20, or the 2.1 hours, right? Okay, so for the first hour, it's 4,000 pounds. Every hour after is 3,000 pounds. So there's our 2 hours right there. The 0.1 equals a total of 6 minutes, right? So we need to figure out real quick how much fuel that is. 6 minutes. We take the 3,000 pounds because it's after our first hour. We divide it by 60 minutes, and that gives us 50 pounds of fuel per minute. Multiply that by 6, that gives us 300 pounds. So add that to our 7,000 pounds, you get the 7,300 pounds. So that's our estimated fuel. Okay. After that, we need to add our reserve of 2,500 pounds, right? Because this fuel, it's asking for your Minto fuel. Okay, max zero fuel weight. The fuel is the ramp fuel minus the release fuel. So ramp fuel, the taxi fuel that we're subtracting is 250 pounds. So ramp is Minto plus taxi fuel. Okay. Minto, what comprises Minto? Bar H, our burn off, alternate, reserve, and hold fuel, right? So burn, alternate, reserve, and hold fuel, we add them together. 2,500 pounds is our reserve fuel. Looking at the weather here at our destination, the wind seemed pretty dang calm. And it's a beautiful day, so I won't add any hold fuel to it. So we'll just call it 9,800 pounds. So 9,800 pounds. Just put that in here. And that's what we call Minto fuel. Okay. Now we've got to figure out the index of that fuel. So we take the fuel index here, go down to 9,800 pounds. We're going to restrict it just a little bit more, give it a negative 2.3 index. Okay. Move that down here. To our 66.6. Okay, now we just take that 2.3, subtract it from our 66.6 that we just moved down. And that gives us a total of 64.7. Is that right? Oh, 0.3. Oh, yeah, there we go. 64.3. Okay, add these two together to give us a total takeoff weight of
68,493. Wait. 58,593 plus the 19.
no 58,693 plus
Ooh, I wrote a wrong number. That makes sense. Oh,
58,693 plus the 9,800 pounds. What does that give us? Derek, how you doing?
oh.
Yeah.
Are you working? Did I just see you?
No?
Your badge is still on, that's it.
Thought I'd come check it out.
Yeah. Have a seat. Pull up a chair. We got some food there.
Well,
If you need some food.
you come by every day now.
Yeah. So what does this end up giving us? The 58,693. So this is Derek. He taught one of the classes a while ago, right?
I probably butchered your METAR learning and TAF learning.
No, we're good. So 68,493. Sorry, we'll finish off this weight and balance, and I'll let you introduce yourself a
No,
little
you're
bit here.
Your last name Holt?
Yes.
I know your name from flight releases.
Oh, I haven't done a release in 3-4 months.
I was gonna say, I quit where I was about a year and a half ago.
Okay.
But you were on them then.
Yes, I was.
So 68,493. Let's see, 68,493 is going to put us about right here with an index of 64.3.
Glad you know how to do that.
Yeah. Luckily, I've been one of Adam's lifer students, so I do a lot of this. Let's see. Okay, our landing weight. Let's figure out our landing weight really, really fast. Okay, so we just take that zero fuel weight of 58,000 pounds, 693, okay, and add 2,500 pounds, because we're only going to land with our reserve fuel on board, right? Okay.
61,193.
61,193. Okay, this is our landing weight. Okay, do the same thing to the index. We've got 66.6. Go up here to our 2,500 pounds minus a 1.5. That gives us 65.5, right?
Right. 65.1.
Oh yeah, I'm sorry, 65.1, my bad. Okay, so now we've got all of our weight and balance done, right? Pretty simple. Just move our landing plot here, 61,193. Puts us somewhere right here. Somewhere in that area. That'll get us close enough. What we need to know is that we stay in our CG the entire flight. Takeoff to landing, right? Okay, so we've got our weight and balance all the way done. I'm going to pause this for just 1 second. We've figured out the weight and balance part. So let's move on to our next step in the flight planning process, okay? So with weight and balance being done, we now have a good starting point to start collecting some data. We're not going to worry about the simplified fuel. I don't want to add confusion onto your guys' process. So what I want to do now is I want to start looking at some weather. Okay. I also want to go through the NOTAMs for everything and just verify that there's not going to be a problem with our departure or our destination, okay? I know we looked at the destination already. I'm just gonna do one final glance through, make sure we don't have to, change up some things. So once again, we're gonna do our scan and we're just going to stay in this column and look at things pertinent to us dispatching, right? We don't wanna waste time on taxiway NOTAMs because that's something the pilot's concerned with. That's not something we're concerned with as dispatchers. Okay, so nav ILS front 19 left out of service. I don't even have to look at the valid date because I know the ILS isn't pertinent to my departure, okay? ILS, once again, nav ILS, we've got obstacles that the pilot's gonna have to be aware of. A couple more obstacles. See a taxiway, another obstacle, obstacle. So we just cruised through 2 pages of NOTAMs in about 5 seconds, right? Just a quick scan. We know that navigational, like I said, if it's an ILS, we don't care because we're not landing at the airport. Our intention is to depart. So we just cruise right past them on to departure airport. Yeah. If our weather's down low, then yeah, we're going to start considering like, okay, do we need a takeoff alternate? And we're going to determine our landing minimums. And when it comes down to landing minimums, what ILS am I going to use? What VOR approach? RNAV. If an ILS is out of service, that's when it's going to affect us, right? But on departure, other than that, when we have 6 miles and sky's clear, just not even a concern, right? We could always get back to the airport.
Plus San Fran, you've got 1 ILS is out. How many runways do you have? If it's St. George, you might be a little bit more concerned, but.
Yeah. So, we take all of that into consideration real quick, make a quick decision, and then move on. Okay, when it comes to FDC NOTAMs, the only thing that we're really concerned about when we've got good weather are our SIDS, right? What departure are we using, and does this affect it? So we're using the San Francisco for departure. So if it's not the San Francisco for departure and a SID, we don't really need to worry about it, okay? This one's the offshore 1 departure. Instrument approach, instrument approach, instrument approach. Here's another SID, okay? So this is talking about San Francisco, California. It's got the AFIVA, City 3, the GAP 7, JNN R2, Night 3, Sehi 3, Santana 2, Stick 3, Turkin. No San Francisco for departure, okay? So we're not really worried about it. These ODPs, these are obstacle departure procedures, okay? So this is if there's an obstacle. Do you think we really care about the obstacle departures? Not so much, right? Especially on a clear day. Again, that's something that the pilots are going to be more concerned about than us, okay? The only time we're going to really consider these, once again, is when it's low visibility, right? When the takeoff airport or departure airport is close to our landing minimums, then we're going to start looking, how is this going to affect my takeoff minimums, right? Or getting back to the airport, okay? Come down here, there's another SID, FDC NOTAM, Stick 3, Westla 3, and Young transition. All of those, once again, no San Francisco for departure. So we're good in San Francisco. There's nothing that's going to slow us down getting out of San Francisco. Okay, going to Kalispell. Once again, the SAC NDB is out of service. Okay. We already looked at the instrument approach plate. It's in there. It's a reference point, but it is not necessary to the procedure getting into Kalispell, right? Instrument approach plate. This is an RNAV. Okay, here we go. ILS or localizer for runway 2, disregard note for the night landing. Runway 12 and 30 is not authorized, okay? So we're good because of multiple reasons. It's not a night landing, so on. So we're good, right? Okay. So we've looked at all of our NOTAMs. We're good. Now let's take a look at San Francisco, and we're going to draw out our plateau, right? A little butte, okay? And yeah, so let me see here. So you draw this out. Okay, we've got San Francisco here. Okay, San Francisco there. What we're concerned about is we're going to write down the winds, and then we're going to write down the temperature and our ISA deviation, right? That's pretty much all we're concerned about. If there's a ceiling layer too, you want to write that down. Okay, so right now in San Francisco, got 8 miles biz, we got ceilings at 700 feet, and then the temperature and dew point is 14 degrees and 12. So what I write down for San Francisco is I write down, I would just do the winds 290 at 7, real quick. 290, 7, and then 8 miles biz, broken 7. I mean, this is just for reference, right, when we're flight planning. And then the 14 and 12 there. Okay, now our ISA deviation, what is the altitude of San Francisco International Airport?
It's
Like 15 feet. It's on the ocean. The approach light system actually extends into the bay. Okay. So we'll just call it 0 for planning's sake. And so what is ISA at sea level? It's 15 degrees, right? What is our deviation? If our temperature is 14, what is our deviation from ISA? -1. So what chart would we use? Which performance chart would we use?
0.
ISA. Okay, so we'll call San Francisco ISA. Okay. So just right here, I'm going to write ISA. That's all we need to know pretty much on here. Okay, so local weather in Kalispell. Remember, we're just going to take, for this class sake, we're just going to take the temperature that it is currently. We'll just use that for flight planning just to simplify things. Just know that when you get out there, you're going to be able to see the forecast and the trends, and you're going to be able to make a decision. But as for now, we're just going to use that temperature that's in the METAR for our destination, okay? Because our TAF, once again, is a forecast, does not have our temperature in the forecast, okay? So we'll take just the temperature of 9 degrees, and that's all we need from our METAR. Then we go down to our TAF at our ETA. What are we planning on happening at our ETA? We got winds variable at 3 knots, 6 miles or greater of visibility, and skies clear. Okay. So VRB at 3. No ceilings, 6 miles, and skies clear. Okay. So that's all we need. Oops. So let's figure out, so it's 9 degrees. Okay, let's figure out ISA at Kalispell, Montana. So we'll go into our Jeppesen chart here, and you can see the very first page, it says airport elevation 2,977 feet. Okay, 2,977 feet, we'll call it 3,000. We'll just give us round to the nearest 500 because that just makes our math more simple, right?
Because I can't math.
Yeah, I don't math. I don't think most dispatchers do math. There's a couple, but what's that?
I just plug in numbers, I don't math.
Exactly. Okay, so we know it's 9 degrees currently in Kalispell, and our standard lapse rate is 2 degrees per 1,000 feet, right? So we take our airport elevation of 3,000 feet, move that decimal place over 3 to give us a nice 3.0, right? Times 3 by 2, and that gives us 6 degrees, okay? Now we've got to subtract that from standard, okay, at sea level, because we are higher than sea level, right? We're 3,000 feet higher than sea level. So 15 minus 6, 9 degrees Celsius. This is ISA at Kalispell, Montana. This is our standard temperature. And our outside air temperature currently is 9 degrees Celsius. So we are at ISA in Kalispell, Montana. Okay, so we're going to use the ISA chart at our departure and our destination. Everybody comfortable with ISA? Feeling good? Okay, we'll do it a couple more times. in our flood
It's
plain.
easy on them.
Yeah. So, don't ruin it for me.
Back to work.
So, all right. So we have now figured out, I said our departure, I said our destination, we're good with our weight and balance, got our flight plan all built. Now we get to start plugging in real numbers here, okay? Oops. Okay. So I'll save this chart for the end. The next step is we need to figure out our altitude capability, correct? Okay. So how high can the airplane get with our current weather information? So a couple things that we need to take into consideration are the departure airport's temperature, the ISA, right? And then we need to take a look at our performance card and see, we look at our takeoff weight, our temperature, and that will give us our altitude capability. So come in here to your flight planning performance charts. We can use either this graph or this one right here, okay? So for today, I'm going to use this one, okay? Deviation from ISA. We are at ISA. Okay? Our takeoff weight is right here. We'll call it 69,000 pounds. And then we're going to penalize that because this is in even thousands of pounds. So we're going to penalize it, throw on a little bit more weight. Okay. So deviation from ISA 0, 70,000 pounds. We're capable of 39,000 feet, 190. Or, yeah, 39,199. Okay. Now, with that number, we need to worry about our course, right? So what's our acronym for that?
Yes.
NEOD Sweden. Okay, if we're going from north to the east to 179, we're going to use odd thousand. From 180 to 359, that gives us even thousand. Okay, so we come in here to Skyvector, we can see that we are definitely an easterly course, correct? I mean, you just look at it. We're going to fly eastbound a lot more than westbound on this flight. So we'll just call it odd 1,000 feet. And take that 39,199, just round it 39,000 feet.
One thing when building flight plans, sometimes you have to go west to go east. ATC, in my dealings, they want you to file whatever you reach your cruising altitude. So if you happen to go west, when you reach your cruise altitude, you'd actually file west. That doesn't mean they won't change you and have you drop down or up when you actually do turn east, but the initial cruise will be your, and that's something that's probably not even relevant,
So once you
but
hit top of line, start to cruise, if you're heading west.
Yeah, then technically you'd fly it at the even 1,000.
Regardless if the rest of the majority of the trip is easterly.
Yeah.
All right.
So that's very, very rare that would happen.
Yeah.
But that's the definition. They want you to plan at your basically top of climb.
And what to throw another kink in that, sometimes ATC, really what at the end of the day, ATC is going to tell them what altitude they want them at regardless. I've had pilots that have been flying east, direct west. We're talking Kansas City to San Francisco, but because rides were better at 29,000 feet, he told them to approve them for 29,000 feet, you know. Even though that's a westbound course and should be on an even flight number, they'll clear them down to 29,000 feet and then just do visual shut. They'll maintain the separation with other aircraft.
ATC will block out that airspace for westbound.
Yeah. So really at the end of the day, ATC does what ATC wants to do. But anyways, so remember this is for planning purposes though. We're gonna plan capabilities. Doesn't mean that that's what's actually going to be flown in route. So
Would that be something that ATC would reject that flight plan for?
no. Not at all. So the things that ATC will reject your flight plans for are procedures not authorized, like those FDC NOTAMs. Let's say that we plan for a departure route that's not authorized, they would reject for that. Or if something that you're not capable of flying. Yeah, so like San Francisco is an example for ERJs. There's an RNAV procedure that San Francisco likes to use when departing out of there. Our ERJs aren't capable of flying that RNAV procedure, and so we have to alter our ATC strip to reflect that.
Due to a
So
software error.
yeah,
Soon it'll be back, but yeah.
but right now,
What does
If-
SkyWest fly here, Jay?
all of
Embraer,
them are, right?
the ERJ would fly more.
175?
Yeah, 175.
Yeah,
We have 122 of them right now,
yeah. We fly for all of our partners ERJs
except
now.
for American.
American, they like the
Seven,
sevens,
maybe.
right?
What's that?
7s and 9s.
7s.
Are we going to get them out in LaGuardia though? Or Dallas Fort Worth? We'll probably fly them out of Dallas Fort Worth.
There's speculation we'll be getting the ERJ for American, but not yet.
Okay.
I know they have them in the system.
Yeah,
His wife's name, Compass.
Compass, probably.
Those flies a lot of ERJs.
Yeah, they're
They're fun to, they're a lot better to jump seat in.
yeah.
A little bit more room.
how do you fit in the jumpsuit in this year, Jay? It just.
Turn into a pretzel.
I pick short flights.
I felt like I was gonna get like touch the captain's elbow or elbows, just sitting there and little legs.
Yeah, they're fun. I enjoy jump seating in anything I can. I prefer the views up in the jump seat than any other seat in the entire airplane. I'll take it over first class on shorter hops. So, yeah, if I'm doing a 4-hour flight, put me in first. But anyways, okay, now we got our altitude. Okay, so let's figure out where our top of climb, top of descent is, and we can start doing our flight plan here. Okay. So, got to come over here to our performance charts. We're going to go to our climb chart. Okay, and we're going to be using ISA. Once again, remember that this part right here, that's the chart. So we need to go where it's ISA, our ISA chart. Okay, we're looking at our takeoff weight, our departure information for our climb. So our takeoff weight was almost 69,000 pounds. We're flying up to flight level 390. So we're going to we'll use these two boxes to find our climb. Just average them out, pretty simple. This is that interpolate. Okay. So what information do we need to pull from this?
Time, distance, fuel, and
This right here. We don't worry about the Mach or rate of climb. Okay. So time, fuel, distance, and true airspeed. So our time, 25.1 plus 26.8. And then divide that by 2.
You never get up that time?
Huh?
Under like significantly shorter flights that
Oh, yeah.
we just.
Yeah, Chicago to Milwaukee, 7,000 feet.
Yeah, we do a lot of flights under 20,000 feet on the short. So it plans it.
LA to Santa Barbara.
Yeah, our software, it typically takes the duration of the flight and limits your, we do a lot of overriding where, like ATC wants Chicago, Milwaukee at 7,000, no matter what. So sometimes when it's hot, like one thing we have to do, Denver right now, it's like ISO plus 20. When it gets above that, we start having issues with the descent profiles won't calculate, or climb profiles. So we have to do a little manipulation, but they wanted 11,000 feet from Cause to Denver, 12,000 feet Denver to Cause. So some city pairs are very specific, but overall, it's based off of what their aircraft can do.
Yeah, it'll take into account the duration of the flight as well.
They don't want to do top of climb, top of descent. They want to be able to at least get in cruise for a little bit because that's where aircraft are more economical in cruise. Mm-hmm. So they try and get it. They pick a happy medium. Yeah,
I mean even our flight St. George Salt Lake is 25 to 27 depending, but. Yeah. But anyways, just take those, add them together, divide them by 2, gives us 25.9. Okay. Our burn is 2355, and the 2491 gives us 2423. Okay. The distance 158.1, 169.4. Gives us 163.7. And then our true airspeed, wow, that's a pretty significant difference. Lot bigger than I normally see. 403 knots. Okay, with this information, do we account for winds on climb and descent? No. Okay. That's a big thing. Okay. So we got KSFO, our route. Okay. Our SID is this SFO4, right? Our true airspeed we use off of that chart, 403 knots. Our magnetic course. Okay. So we're just going to go to Skyvector.
I don't think that's the true airspeed. You were looking at the
You looked at,
below it.
you looked at, feet per minute.
Oh, did I?
Yeah, it's
Oh, okay.
378.5. There's only 1 mile.
We would round it to 379 anyway, right?
Oh,
Well,
my
I
bad.
thought
I
you
did.
were funny.
I did look at the.
Yeah,
My bad.
Yeah, when you said
There's
there's
a
a
big
difference,
difference,
like,
like,
I was
the
wrong
thing.
thing.
Sorry, yeah, I was looking at rate of climb. That's why it's a significant difference. I was like, that looks a little off.
Just keeping you guys honest.
Yeah, I did it on purpose.
You guys
379.
passed, you were paying attention.
Totally me.
Yeah, it's a joke. Gotcha, guys.
So 379 knots. Okay, Skyvector. Jump in here and pull your heading off of this. Gosh, I really don't like how they changed Skyvector to not give us a heading per leg. So here's a cheat.
Yes, please, I struggle.
You guys ready for this? Watch this. Click that button right there.
Are we allowed to use that?
You're allowed to use Skyvector now.
The
Yes.
whole of
The whole
Skyvector?
program.
Just so you guys know, Skyvector is not an approved source at SkyWest.
Yeah.
I use it all the time, but it's not an approved.
Yeah. Don't.
It's an amazing product, but yeah.
Yeah.
I can
If they
use
catch
it.
you using it, you can get your hand slapped. So it
Not
is
by me.
for reference. It's for reference
Is it the
only.
Wikipedia of aviation?
No, it's very. The problem with airlines is you have to have approved sources for weather. You have to have approved sources for flight planning that the FAA has to vet. Skyvector, as far as I know, isn't vetted by the FAA. It's. I wouldn't lump it into Wikipedia, but it's.
Not everyone can go in there and alter the.
It's a good example. It's a good example. You can't go in.
Say
Yeah,
they're
people
administrator.
can't go and alter it, but it's not a source that has been vetted. So I use it all the time in planning, basically because it does give a lot of information that's easy of use. But then I'll go and verify it with our sources. Just like weather, I can use the National Weather Service, the TAFs that they issue, but we can also contract with it's called the Weather Company, formerly known as WSI. we can ask them to do a new calf. So it's kind of the same thing.
Yeah.
But
So that button, all it does is it turns it from a flight plan like this into an actual IFR flight plan. Okay. So this gives us a heading right here. San Francisco to Red Bluff, we fly a heading of 284. You're welcome, okay?
Like, seriously.
Not only do you guys get to cheat and use Skyvector for your practical, unlike every class prior to, but now you guys know the cheats, okay?
just so you guys know, I had no clue of Skyvector 10, 11 years ago when I did my license. It
Yeah.
was all charts, paper charts.
You know what was even more sad was that
It's crazy.
I had gone through class, so I was in Adam's first class. We started with Skyvector, but had to use paper charts on the practical. And then there was a period of time where they allowed you to, or they didn't allow Skyvector. And then they went back to Skyvector, and now the new inspector for SkyWest, he's also the guy that is over this area, and
Stu.
yeah, he's now doing this class as well. Like, he's the inspector for this class.
Have you guys met?
He's come in and approved the Skyvector again. So
Has he come in?
no,
He's a really laid back guy. So if you do meet him, he's real cool. He dispatched at Delta for numerous years.
Oh,
Where'd
why
you get
you
your
don't-
license from?
That was a place called Airline Ground Schools. It's now called Flamingo Air Academy in Cincinnati. I don't know where they get Flamingo in
Cincinnati.
Ohio, but
Well, today.
I did it kind of like you guys, where I had my commercial license when I started, so they allowed me to do everything online, and then I had to do a week back in Cincinnati.
I still like that.
Yeah, I like the format, so. But it wasn't nearly, we didn't do actual class like you guys did. I like that format. Mine was all self-study. I studied the ADX all on my own.
I make them study the AEX on their own.
Well, I mean, like, I didn't know anybody to like call up and say, hey, what'd you get for this answer? It was where you guys have the support. But
Yeah. Okay, so there's your cheat, 284, right? It even gives us a distance, 156.5. You guys are so welcome.
What do you need? You just discovered
Hey,
that?
who was your favorite dispatch teacher again?
Oh, dude, it was you from the
Okay.
food. You didn't need to have
I
a
know,
chicken.
now I've just put it over the, that's the cherry on the
is this your first week here?
second.
Second.
Yep.
So you guys are cramming.
Yeah,
Got one more week.
Did you know that the whole time that this feature was there?
yes. So, 200, hey, a lot of
Oh, no. No.
No, a lot of stuff with dispatch is you have to know where to find the information. And so we do offer, especially at SkyWest, we offer ways to condense all the information, bring it in from different sources, but you need to know where to go. When you do your practical, you need to know where all the information is. In fact, it's still open book, right? They allow you to use all these sources on your practical.
it's not open book, it's not open notes.
Yeah, it's not open notes, but they do allow you to use some of your training books, manuals to,
I don't know.
no, they don't do that anymore?
No, so it's a,
Were we supposed to get training in?
yeah, so, I mean,
Okay, scratch what I say.
as far as the practical goes, it's as far as notes, no. Greg does a really good job of helping steer you guys to the right answer. He's not going to be like, oh, you said this when it's really this. He's going to be like, now let's think about that for a second. We'll come back to it. And then he'll go back to it in a roundabout way. We'll talk about something else. He'll ask you another question that starts guiding you to the answer that he was looking for. And then he'll revisit the question and say, okay, now that we know A, B, and C, what is this? You know, he's really good. There's only one person that's ever failed one of Greg's practical tests, and it's because he literally like did not answer a single question, right? Like he just completely shut down and was just like, yeah, I don't know. Yeah, I don't know.
Schedule me today.
Yeah. So it was just like, okay, you need to go and study this, and this. We'll come back and we'll only talk about this, and this. You did good on your flight plan, but now we need, on the oral part, we need to go back and review some things. So,
Little word of advice, never offer too much information.
yes, answer the
Oh.
question,
Answer the
the question
and
only.
stop.
And that holds true with everything you do in aviation. Only enough information to get them through.
My biggest thing is I'll go on tangents. And when I got my private license, we did the same thing. You have an oral and then you go and fly. So it's kind of the same thing, other than you guys won't go out and fly. But I had a big problem with offering too much information, and I almost hung myself with it. So just answer the question and stop. Wait for the next question.
It's good. It's sound advice.
And be confident in your answers.
Yes. And if you don't know, don't try to answer the question.
And if
Think
you
about
answer
it
the
for a
question,
second.
Say, and Greg will sometimes he'll go, and no, that's it. Oh, okay, and move on. So he tries to get you. He feeds you the rope. He's trying to get you to.
I would really struggle with that.
Be careful.
Oh my gosh.
It's gonna be like, wait, there's more?
Oh, I'm gonna go on a
So,
tangent and it's gonna be.
Beware of that
like,
little
it's a
thing.
full
If you
something
guys are
fun.
confident with your answer, say no, that's the answer. There's nothing else that I can tell you at this point. Okay.
That's it. That's all.
What is that?
Yeah.
Unless there really is more information on this.
I feel like you're leading us astray.
Yeah.
Answers here.
There's like a whole other part, and you're like, that's it.
Oh my God, where's my car?
Answer the yeah, definitely answer the question when he's asking.
Oh, you should.
So the rest of this, we just throw in the information we already pulled off of our performance chart, our distance. Remember, this is to the top of climb. We're not doing a segment here. This is top of climb,
Can you zoom into this? Is that a possibility?
I guess.
Thanks.
Just for you.
Appreciate it.
Okay. So 163.7 for our distance, 25.9 for our time. And our burn came to a total of 24.23. Okay. For this part, we take our aircraft weight. So this is our planned takeoff weight of, what was it, 60?
69.
Yeah.
Round up to 70.
Six. Well, this one we're going to pull the actual number we spit out here, 68,493. So, let me get this out of the way. 68,493. Okay. Then we're going to take that 2423 here. And subtract that from that 68,493. That gives me a total of
66,070.
66,070. Okay, so there's our first leg. You guys cruising along. Okay, top of descent to our destination. Oops. Okay, we're going to KGPI. Okay. We are, on this one, we're just going to go direct from FCA. So I would just put DCT FCA. really it doesn't matter so much what you put there. If it's a sit or a star that you have that you're using, put that there for the arrival. If you don't have something like that, just say direct whatever the VOR that is closest, okay? Remember, this is our descent, so I usually just put a down arrow like opposite of what you see in the first box up there. But since I'm using my computer here, I'm just going to say we're going down. Okay, our true airspeed. Let's go back over to our performance cards. Okay, we're going to go to our descent cards. We're using ISA once again because we're using our destination airports ISA deviation, right? So descent, ISA, and we're going to go to our landing weight that we figured out, 61,193. And we're just going to round that up to the next 1,000, really. I mean, we're going to add 300, right? Because that's a good average for our descents. That'll get us 61,400 almost. Just round that up to the nearest 1,000, 62,000 pounds. Okay, so ISA 62,000 pounds from flight level 390. I'm going to use this box right here. Okay, just write down the information in that box. 17.3, 383, 109.9, and 381. Okay. Now we just got to regurgitate that onto our chart here. Okay, our speed was 381 knots. We're going to come over here to Skyvector. And we're going to do just an average here. So to Glacier Park, it's going to be a directive 313, but we only fly that for 6 miles. So we won't really use that at all. Okay, so from Spokane to FCA VOR is 052. Our distance that is flown from the top of descent is 109. So we know our top of descent is somewhere between these two, so we're just going to use that 052 degree as our magnetic course here. Okay, we're using the ISA chart. 052 because we're not correcting for winds. And our true airspeed of 381 knots. Okay, take that, the rest of the information we came up with from our performance sheet, put it on here. This one we're going to put on the plus. You guys see where it's a plus and not an equal sign? Okay, so for GPI, our segment distance was 109.9, correct? Okay. Our segment time was 17.3. Our segment burn was 383 pounds. And there you go. So down here in this minus, we'll just put 383 pounds there. And that's all we're going to do for our top of descent. Okay. Does everybody's sheet look pretty familiar to that? Or pretty similar to that? Sorry. Okay. Now we get to start planning legs. We know where the top of descent is. We know where the top of climb is. And so we need to go define those on the map and then create the legs, right? Okay. So our total distance, just a quick look at that, 800.7, 800 miles. Okay. We like to be around how many miles per leg? 250 gives us pretty accurate performance data. 150 to 250 is where I like to be. So we know that we're going to have, what, 3-4 legs total. So.
Wait, we legitimately don't even have to calculate the math between the two. Oh my god. Okay, cool. We're good.
What?
No, you're fine.
Okay,
I'm just confident.
good. All right, so going back to our little cheat sheet here, 156.5. We know that our total segment distance for top of climb is 163.7. So we know that we can take this 163.5 from Lakeview VOR to Red Bluff to Lakeview VOR. We know from this VOR to this VOR, it's 163.5. Just take the difference of, let's see, 156.5 plus, here we go. So our total distance to top of climb is 163.7. We can subtract the 156.5 from San Francisco International to Red Bluff VOR, and that gives us 7.2 miles. So we know that our top of climb is 7.2 miles past Red Bluff. So now we just take that 7.2 and we subtract it from the 163.5. And that gives us 156.3 miles. So we know to, from our top of climb to Lakeview VOR, that is a total of 156.3 miles. Okay. From Lakeview to Kimberly VOR, that's 133.9. Oops. So that gives us a total of 290 miles. Okay. So you guys decide, do you guys want to go all the way to Kimberly VOR? And then from Kimberly to the top of descent?
Yes.
You guys just want to call it 2 en route legs?
That's 40 miles.
All right, then let's do it.
What's gonna happen in the back?
Whatever you guys come up with, it doesn't, as long as your performance, your fuel burns come close to his, that's all that matters. So the more legs, the more accurate the number, the less legs, the less accurate. Okay? Yeah, you're gonna be like, if you want to nitpick and go VOR to VOR, go ahead. That's fine. But let's speed things up and we'll just do the 2 legs. So from from top of climb to Kimberly, so IMB is a total of 290.2. Okay. So now let's go backwards from Kalispell to our top of descent. Okay, that is a total of 109.9 miles. So we can see that from Glacier Park to Spokane, if we add these two numbers, 144.7 plus 6.6, that's a total of 151.3 miles. Okay, if we subtract our 109.9, that gives us 41.4 miles. So we are 41.4 miles from Spokane, VOR. Does that make sense? So from GEG to top of descent, it's 41.4 miles. Okay, now let's figure out how far it is from Kimberly to our top of descent. Okay, so we just take that 195.5, add on our 41.4, and that gives us our distance. 236.9 miles. Not too shabby, huh? So IMB to top of descent, 236.9. Okay. So our top of climb is like right here. Here's the center point of our flight plan, and our top of descent is somewhere about right there. Everybody good? Okay. So let's put that information in here. So top of climb, we're going from top of climb. All right. Well, thanks for coming in.
I'll try and swing by maybe tomorrow or something. Head
All right.
out of town, so.
Yeah, anytime.
See you guys later.
Thank you.
All right. So top of climb to IMB is our first leg. The jet route that we're on for that leg, you can see that J3 is pretty much the only jet route we fly on, right? This pretty much takes over 90% of our flight. So we'll just throw in J3 here. Flight level we're going to be flying at 390. True airspeed, we're going to figure out really quick. So we come back in here. Oh, we need to figure out something before.
ISA.
Okay, we need to figure out ISA. Okay, so we come down here to our winds aloft chart. When you guys are flight planning, I want you guys to look at these charts that we provide too. I don't want you guys flying into these red boxes, the red nasties here. Okay? Those are probable thunderstorms, and you can see the tops that they're reporting. Those are forecasted thunderstorms, so with a really strong convective activity. So you can see the tops are going to be like 39,000 feet there, 40,000 feet. Can't really climb over those, right? So just take a look at the weather, just kind of brief yourself on the weather that you're expecting in the route, in route. You can see that we pretty much avoid all weather. We stay just on the east side of that cold front there. All the weather's on the west side of the cold front there. So, yeah, just take that into consideration when you're doing your flight planning. You can see it there once again. Okay, so we know in our climb We're going from San Francisco to Red Bluff, and Red Bluff's where we top out. So let's take Red Bluff to Lakeview, or actually we can look at Red Bluff all the way to Kimberly VOR here at 39,000 feet. That's going to be, we can use that for our ISA deviation. So ISA deviation, how do we figure this out again?
Take that elevation with the decimals over 3 times
Okay.
by 2, and then subtract from 15, which is
So
always positive.
39.0 times 2 gives us 78. Okay, we take 15 degrees of standard at sea level, subtract 78 from it, gives us negative 63. This is ISA at 39,000 feet. Okay, our current temperatures at 39,000 feet, we'll just take an average of that, call it 54 degrees. We are how much warmer than ISA?
It's 10, 11,
9 degrees.
9.
9 degrees warmer. Okay, ISA plus 9. So we're going to use the ISA plus 10 charts. Okay. That's for the first leg. Now let's see Kimberly to Lewiston, Idaho. 57 degrees. Negative 57 degrees, right?
So that's 6
So it's 6 degrees warmer. So what charts are we going to use?
Plus 10.
ISA plus 10 for the whole route. Okay, so for this first leg, we're just going to take an average of the winds here for our first leg. Okay, so somebody average these out real quick. So for the heading, 230 plus 210 plus 200. What's our average there? It's going to be like 220.
What are the numbers again?
230 plus 210 plus 200.
213.3.
So 213. Let's call it 213. So winds 213. And then for speed, somebody averaged these out. 75 knots, 87 knots, and 91 knots.
84.3.
84. So we'll call it 84. So 213 at 84 knots for that first leg. Okay, the next leg is pretty simple, right? We can just average these two. 209 or 2020, that gives us a heading of winds from 200. Okay. 91 and 82. It's 86, 87. What is it? So we'll call it 87 knots. Okay, 200 at 87 knots. Okay, we've got our winds and our ISA deviation for our en route section now. Everybody following along good? Okay, so the true airspeed that we're going to pull off of our chart, I'm sorry, got to go back here to my charts. Okay, so we know that we're using the ISA plus 10 chart. At the top of climb, we were at 66,000 pounds. So 66,000 pounds, ISA plus 10, 39,000 feet. We're just going to use this box right here. What numbers are we concerned with en route?
pound-hour engine and rear speed.
So we only care,
True airspeed and per hour.
about those two numbers right there.
Is
You can
that
still
one
see
right
it.
above the true airspeed? What is that? It looks like it was. both
Indicated airspeed.
Oh, that's 9, got it.
Yep, so that's what the pilot's gonna be reading on his speedometer. Okay. So this is pounds per minute pounds per engine per hour,
Per minute.
pounds per engine per hour. And then that's knots true airspeed. Okay, so let's do that leg now. Because we gotta have this data to get our next data. Okay, so knots true airspeed, 451 knots. Ugh. Garbage. Okay, 451 knots. Okay. Our magnetic cores,
What was the weight that we were using? 64?
66. Look up here at this chart.
Oh, I'm using +5, sorry.
So this chart right here, we just look at our aircraft weight right there.
I was just on the wrong chart.
All right. Okay. Magnetic course, pull it off a Skyvector, pull an average. Okay, Red Bluff to Kimberly, we're flying a portion of that at 163.5, so 164, and another portion of that at 134. So 164, 134. So 149 degrees. Okay. I'm just going to put plus 10 in here. And then for our winds, we've got 213 at 84. Okay, now we're going to use our handy dandy E6B. Our true course, the first number that we are going to put in is going to be that 149 degrees. The next number is the true airspeed of 451 knots. Our wind direction is 213, and the wind speed is 84 knots. So that gives us a ground speed of 408 knots and a true heading of 159 degrees. Slowing us down, isn't it? Okay. Now our total distance that we had there was 290.2 miles. What we figured out earlier, right? 290.9 or 290.2. Okay. our segment time. Okay. So we've got our distance of 290.2. 290.2. We don't know our time, but we know our rate of 408 knots. So we just divide our distance of 290.2 by our rate of 408. And that gives us 0.71. And to convert that to minutes, we divide that by 60. I'm sorry, we multiply that by 60. 0.71 times 60 is 42.6. So 42.6 minutes. Okay. And now we need to figure out our burn. So we just take that 42.6 minutes. Remember that number. We need our burn of 1549. We multiply that by 2 and then divide it by 60 minutes. So that gives us our total burn when we multiply it by 2. And then when we divide it by 60, that gives us our pounds per hour, or pounds per minute. Okay, 51.63 pounds per minute. Multiply that by our 42.6 minutes, and that gives us 2,199.6 pounds. We'll just call it 2,001 or 2,200 even. Okay, let's just round that to the nearest pound. So 2,200 pounds.
You walk me through that again. That's the one step that I always get lost on.
Yeah,
Okay.
I'm struggling with that too.
Okay, so let's see. Okay, so we figured out our total. We figured out our total distance, right?
Right, it's 42.6.
That's our distance.
No, our distance is 290.2.
290.2. Okay, so 290.2. That's our distance. We divide our distance by our rate or speed, or our ground speed. Okay, that's how quickly we're moving across the ground. That was 408 knots. Okay, that gives us 0.71 of an hour. So almost 3/4 of an hour, right? To convert this time to minutes, we multiply that by 60, and that gives us 42.676 minutes. 42.6, that's
Tracking up to there.
okay. Okay, now to convert our fuel. Okay, we take the performance burn we got off of this chart right here. Okay, that 1549.
Okay.
That's a pounds per engine per hour. Okay, so we have 2 engines, so we multiply that by 2 to give us a total of 3,098 pounds in an hour. That's how much fuel we burn in an hour. Okay, now to convert that to what we need it to be, we need to know how many pounds we're going to burn over that 42.6 minutes. We need to convert this first to minutes. Pounds, how much fuel are we burning per minute? So to do that, real simple, divide it by 60, and that's how many pounds of fuel we burn in 1 minute. So 51.63 pounds per minute. Now you just multiply that by how many minutes you have, 42.6. And that gives us our total of 2,199.58.
Okay. All right.
Let's round to the nearest pound. We like round numbers with our fuel burns, okay? So 2,200 pounds. So we just subtract that from the fuel that we've already burned.
63.70.
And that gives us 63.70, you said?
63,870.
Okay. So at the beginning of our next leg, we weigh 63,000 pounds, or 63,870. Is everybody good to there? Okay. Now let's take this these boxes here and let's bring them down too. So we take that 163 miles, add on our 290.2. What does that give us? $453.9. Everybody get that? Okay. Our segment time, 25.9 minutes plus 42.6.
68.5.
68.5. Okay. And now just add our two burns together. What was that?
46.23.
Okay. That's our total that we've burnt since we departed San Francisco. Everybody good up to that point? Okay. Now we just have to do it one more time here. And this leg, we're going IMB to our top of descent. Okay. So to get our heading, the route that we're using, once again, we're staying on J3, a little bit on Victor 448. We'll just call it J3. Okay. Is he going to penalize you if you put Victor 448? No. We're staying at 390. Our knots true airspeed. So this is where we go back to our performance charts. But this time, rather than using 66,000 pounds, we're going to use 64,000 pounds. Just round this number to the nearest thousand. Okay. So 64,000 pounds for our flight planning charts. We're staying on the ISA plus 10 for this section as well, because we were, ISA plus 7. So we'll stick to our more penalizing chart. And we are going to be right here. So flight level 390, 64,000 pounds. Right there. So once again, we're only concerned about this number right here and this number right here. So 15, 14, and 451. So 15, 14, 451. I'll just write those down real quick. Erase the drawing here. Go back on to this. Now we have all the information pretty much that we need. Oh, there's one more thing we need. Sorry, my bad. Okay, we're going from Kimberly VOR here to 41 miles past here, right? So our main heading that we're flying here from Kimberly to Spokane is going to be 6 degrees. Just find the average of 6 degrees and 52 degrees. What does that come out to be?
29.
Huh?
29.
29. So that's what we're going to put there. So 451 was our true airspeed. 29 degrees, 029 is our heading. Once again, we're using the plus 10 chart. Our winds that we figured out here were 200 degrees at 87 knots. Now we go back to our E6B. Okay, on our E6B, the true course that we're using now is going to be 029. The true airspeed, 451 knots. Our wind direction, 200, and the speed, 87 knots. Okay? That gives me a ground speed of 537 knots and a true heading of 31 degrees. Pretty simple, right? Okay. Let's do our segment distance here. We already calculated that out. So the total distance from Kimberly VOR to our top of descent, 236.9. Okay. Segment time. So we have, once again, we have our distance and we have our speed. Divide our distance by our speed, and that gives us our answer. So we divide 236.9 by our speed of 537 knots. We're using our ground speed here.
2647.
Okay. 0.441.
Oh, we multiplied it by.
Oh, you already did it? Oh,
On the.
okay. I was like,
Yeah.
I was like, huh?
Does it too.
Oh, you did it on the E6B? Okay.
Sorry.
That was another pro tip I was going to give you guys.
Oh, that's so cool.
Okay.
What?
So,
Didn't mean to skip ahead of
yeah,
yours.
you're good.
Pro tip.
You're good.
Activate
Shut the front door.
We'll come back.
What?
We'll come back and hit that.
This is- Alright,
Okay.
cool.
So that gives us a total of 0.4411 times that by 60, and that gives us 26.5 minutes.
Hot damn.
Okay. 26.5 minutes. Now we've got to figure out our fuel. We are burning 1,514 pounds per engine per hour. So we take that, times it by 2 to give us 2 engines, total of 3,028 pounds per hour. Okay, divide that by 60, and then multiply that by our 26.5 minutes for that leg. That gives us 1,337 pounds of fuel. Actually, let's just call it 1,338. You guys, it doesn't matter, right? Pound difference isn't gonna,
13:38.
yeah, 1338. Okay? Subtract that from our total here. So 63,870
62.
minus 1338. 62,532. Throw that in there. Okay. 453 miles. Total distance 453.9. Add on our 236.9. That gives us 690.8 total miles so far. Okay, take our segment time, add that onto our,
95.
what is it?
95.
95 minutes. Okay, add our 1338 onto 4623.
5,961.
5,961. Okay, there you go. I did this around here. All right. So now we're pretty much done. Now we just bring everything down here. So 690.8. Was that what we calculated out? Okay. I love it when a plan comes together. $95 plus 17.3 gives me 112.3. 59.61 plus 38 or 383. 64. 63.44. Okay. And 62.52 minus 383.
62,139.
62.149. Boom shakalaka. Okay.
Does he want to see us fill out all the miscellaneous boxes?
Yes.
What?
All the boxes
Oh, the
done.
below. I was like, why?
I want you guys to be able to fill out the entire flight package. So we're just gonna go over this part.
Yeah.
We're gonna go over this part here.
How long would it take you to do this? If you're doing this, just longhand, you're doing all the boxes the way we're doing it. How long would it take?
Well, it's only been, what, 2 hours since I started this? Take out all the talking and other stuff. We're at about an hour and 20 minutes. It's not too bad, right? Now the rest is just filling out information that we already compiled, right? So our top of climb, our time was, can just come up here, 25.9. Oops. The fuel was 24.23. The distance, 163.7. And our fuel, our knots true airspeed was 379 knots. Okay, top of descent, time 17.3. Fuel 383. Distance 109.9. Knots true airspeed 381. Okay. Our burn off that we came up with here was 63.44. Add 63.44 plus our 2,500 pounds gives us 88.44.
Wait,
Didn't have any hold fuel.
you go like your alternate?
Oh, no, sorry.
Yeah.
It gives us our total here. Okay, to get our ramp weight, we add 250, 90.94. Just out of curiosity, let's go down to our weight and balance, 9,800 pounds. So we're like 700 pounds off of what we had estimated. Okay, a lot of it is due to that 537 knots we picked up. It's a nice wind. All right, now we just take these and put them where they belong. So you can just take this first arrow and drop it in here real quick, 63.44. Take this arrow here of 88.44. Our bow weight was what?
44,843.
44.843.
43.
Okay. Payload, passengers and bags, what did that come to?
58,593. That's a zero fuel line.
58 what?
593. No, 693. I don't remember. It looks weird.
693. Are you adding them to?
No, that's our zero fuel. Yeah, so
Yes, 13,850.
Wait. Oh, got it. My bad.
okay. So this equals our takeoff weight when we add our fuel onto it. So 58,693 plus 888 or 8,844.
67,537.
Okay. Our landing weight, when we subtract the 63.44, 67,537 minus 63.44,
61,193.
61,193. And this
That's
page,
where the magic happens.
yep, exactly. So there we go.
What about the other sheets in this packet for my annex ones?
Huh?
Like, do you wanna see this filled out?
Yeah, we're gonna fill out all of the rest of the packet real
Do
quick.
you wanna see this one filled out?
All of the packet. Okay, so we'll start with our airport information here. Departure airport, KSFO. Okay. Our time of departure, 09:45. Our weather at 09:45. You can just take this TAF line, or I'm sorry, the METAR, up to their mark. Just slap it in there. Okay. Runway that we're going to take off. Let's go pick a runway real quick. So our winds are 290 at 7 knots. Okay. Looking at San Francisco Airport and doing the best for winds. We've got, can everybody see it? Okay. Your runway numbers are down here in the corner. So we got 19 right, 19 left, 10 left, 10 right, 1 left, 1 right, 28 left, 28 right. So our winds were 290. What runway would you guys pick?
You said it.
290.
280 left, 280 right.
Yeah. Use the 2/8. Perfect.
What side of the runway are the signs on?
It doesn't matter.
So 280 right.
Just,
It's what the
You got
pilots.
2-8, right, you're going up.
just for my own ADX curiosity. I'm wondering, are the signs on?
Well,
Well, it depends.
both sides.
Yeah. Huh?
Yeah, that's the one that's up.
Both sides of the taxiway.
Yeah.
That's what I
And it said you had it wrong?
Yeah.
So I put two, I didn't do my review. That's what it is.
What did you put?
Yeah.
I didn't bother to review.
They're on both sides of the taxiway. The signs up.
I didn't need to, I was like, I passed on you, Brad.
Over it. Don't even care. I was like, are you sure you don't want to go with us? Like, I don't care. Hard pass.
Yeah, I've already.
Wait, I am still confused on that. Why are we choosing that? I guess I'm not.
Because we're going into the wind, it makes
Yeah.
sense we're going to the wind.
So the winds are
Where's,
coming.
how are we getting that 280s from that direction? I guess where it was.
So runway heading, just like winds, are reported in 2-digit, like our winds aloft chart, right? 2 digits.
Oh,
Put a
good.
0 on the
Got
end.
it. That's all you need to say.
Yep.
Okay, cool.
So we match our runway to our winds
Yeah,
so that we're taking off with a
that was a
headwind.
lot simpler than I thought.
Yep. So 2/8. I'm just gonna say 2/8 left. Okay. Takeoff minimums. So this first box is asking for standard takeoff minimums. My standard takeoff minimums for runway 28 left. Runway 28 left, 28 right. Standard 1 and 2 engines. Boom. Right chair. Okay.
50 or 1 or just 1?
So 50. RVR 5000 or 1. So you can put them both in here if you want. So that's your RVR or 1 statute mile. Oops. Okay, less than standard RVR. We're we're going to use that. So our RVR is 1600. And our visibility is 1/4 mile. Touchdown zone, midpoint, and rollout with everything up and running. 500, 500, 500. Fives across the board.
So I'm assuming he's gonna give us jet charts, or he's gonna give us like a book full of jet charts?
And he's going to give you the jet charts for the route. Okay. There you go. There's the first one. Okay, everybody good with what we just did?
Yeah.
Pretty simple. You're just taking the 10-9 alpha chart and putting it on here. Destination chart, or destination airport.
Would it make sense to do this one first?
No. It doesn't really matter. I mean, we dispatch airport to airport. This is more for pilot reference. As long as we know that we have a usable runway at takeoff, we don't really care dispatch-wise. This is just for performance.
I'm just trying to go back to one of the very first things when we talked and looked at the sheet. You had said Adam prefers to do this other thing first, you prefer to do this one first.
Yeah,
So I could-
yeah. And so yes, when it's me flight planning, preferred this one. On your guys' practical, so anyways, the ETA that we planned out, let's go to our weight and balance chart really quick. Or not our weight and balance, let's go to our IFR flight plan. We got a total time here of 112.3 minutes. So 112 minutes, add that onto your ETD of 945. What is our ETA? So 945, that's just shy of 2 hours. That's 8 minutes short of 2 hours. 11:37. Okay. ETA 11:37. Zulu. Weather at ETA. Let's go over here to our flight plan. Or I mean our route briefing guide. We're going to take the TAF and that's what we're going to paste in there. Okay, runway. Does it matter what runway we choose when it's variable at 3 knots? No. So let's just go and pick a runway, an old GPI. Don't even need to think about this one too hard. So what runways do we have at GPI? Yep, 2, 20, 30, and 12. What runway do you think we'd use? Probably the longer one, and 2 is an ILS and everything. 2 is probably our number 1 choice.
2 is number 1.
Yep. So runway 2. It's asking, is this grooved and do we have a headwind? We have no wind. And to figure out whether or not it's grooved, we can look at this chart here. Runway 2, grooved. Super simple. So, let's say something like that. We'll call it a headwind and we'll say it's grooved. Okay? Instrument approach. What approach do we have for runway 2? Let's go down to our, we can come down here to our ILS, to our runway 2, see that we have an ILS. So we'll say that it's ILS.
Could you go down to those?
Yeah. Yeah, our ILS or localizer, but if it's an ILS, then we automatically can assume that it's localizer too. So the ident or frequency that this approach is using is 111.5. We find that up in this box. You guys remember, right? 111.5. Okay. What do we have for our minimums? 200.5.
Where did you say that?
1 second, we'll go back. Okay, where are our minimums? Does everybody remember where to find the minimums?
Bottom,
Bottom left-hand corner, right?
I see. Is that for, it says 3166, is that for the,
That's the decision altitude. So if we take 3166 and take the runway elevation of 2966 and subtract it from that 3166, 200 feet. So the altitude is the altitude above sea level. The decision height is 200 feet above the runway. Okay? Since nothing was notumed out, if you guys remember back to our notums, the only notum we had was the SAK VOR was out of service. Or SAK NDB was out of service. That's not part of the ILS system, so we can assume that we have a full ILS here. So 200.5 are our minimums. Okay? Notums. NA. And that's all we need to do. This chart is done. If we had a takeoff alternate, we can fill out the box right here for our takeoff alternate. If we have a destination alternate, you can fill it in this box. Okay. Everybody good? So that chart's done. Weight and balance is done. That chart's done. Performance worksheet. Okay. Fill it out. Flight 3. Date is 6/11. Go from KSFO, KGPI, Captain Phillips, and prepared by you. Okay. Organization, KSFO. Runway that we chose was 28 left. What flaps do we use for takeoff? Which one do we use? Oh, you said 8 degrees? I thought you said something else after. I'm sorry. Outside air temperature that we planned out was 14 degrees. And what do we put here? 75,000 pounds. We'll just use this MGTOW for that. We don't really care so much on this. Okay, GPI. We chose runway 2. What flap setting do we use for approach? Huh?
45.
45 degrees. Planned outside air temperature, 9 degrees. And once again, we're just going to take this MGLW, 67,000 pounds, and call it gravy. So since we don't do a simplified flight planning anymore, for our burn, let's just go ahead and slap in the number that we came up with. Of 63.44. Add our reserve onto that. We didn't have an alternate. We didn't add contingency fuel. So that gives us 88.44. Add on our taxi at 250 pounds. What was our ramp fuel? 9,000. Huh?
9094?
9094.
I know, no.
Did I catch a niner in there? Were you calling from a walkie-talkie?
Yes, sir.
All right. Time to destination. Okay. Time to destination. What was our minutes? 112. 1 hour and 52 minutes. Okay. Didn't have an alternate, didn't have contingency fuel. So our fuel time equals a total of 2 hours, 37 minutes of flight time. Good? Everybody tracking?
Yeah, buddy.
Okay, airport. What? Okay. KSFO,
Oh, you're like, oh, time.
elevation. Let's figure out the actual elevation of
Didn't we say 15?
13 feet.
13.
You're fine. Takeoff runway 2A left. Oops. Right? No takeoff alternate. Okay, now we got this little thing that we got to deal with called V1, V2, VR. Ooh. So let's go over to these charts right here. I got the pretty airplanes on the front. What was our takeoff weight? 69,000 pounds, approximately. 68,870. Okay, for this class, we're taking off with flaps 8. Our pressure altitude, we're not actually going to go figure out. We're just going to use the altitude of the airport, the elevation of the airport. So 0, our outside air temperature.
Where's this, is in the product charts?
Yeah, so this is the one with the airplane on the front. Okay. So at 69,000 pounds, we're just going to use the elevation of the airport, and then we're going to use the degrees, the temperature that closely matches our temperature. Okay. 128 knots. Okay. $128 for our V1, our VR 129, and our V2. So we're going to use the V2, the first number, 139 knots. So 128, 129, 139.
Yeah.
Oops, my bad. 128, 129, 139. Okay, takeoff stab trim setting. This one is this loan sheet right here. You guys remember how to do this one?
Okay, percentage from the.
Percentage of MAC. So we just go straight up on our weight and balance sheet. We go straight up to the top here. 26 point blah. Pretty close to 27. We'll call it 27. Okay. So percentage of MAC, 27. Our takeoff weight was 69,000 pounds. So our stab trim setting is 6.3.
Jeez, it's amazing planes get off the ground, huh?
Yeah.
Off of the- Show that again, please.
Okay, so let's go back down to our weight and balance. So we come to our index that we got on our takeoff numbers. Our takeoff index was 64.3, followed all the way up to the top, and that gets us pretty close on this percentage of MAC. That gets us pretty close to that 27, right? I mean, it's like 26.8 or something like that. We call it 27. So 27 percentage of MAC. This is flaps 8 up here. So 27, go over to our takeoff weight of about 69,000 pounds. Gives us our stab trim setting of 6.3. Alrighty, destination. Okay, GPI. Airport elevation was 2977. Landing runway 2. Landing speed. So we use the same exact charts with the airplane on the front. This time we go to our landing weight. Okay. So our landing weight was, we're looking off of this, 61,193. So 61,000. Yeah, we'll call her 62. Okay. So 62,000 pounds. In the bottom here, you can see where it says landing. What flap setting do we use for our landing? 45. So VREF is our landing speed, 129 knots. Don't have an alternate airport, don't have an alternate landing runway. So there you go. Another chart bites the dust. Now we just put it all onto here. 611, Captain Phillips, Dispatcher is you. Okay. This is original release. Okay, we're flying IFR2. I'm going to knock that one out real quick. This is not an amendment. This is an original release. Okay, flight number 3. Aircraft number was 754 Sierra Kilo. We were going from San Fran to Kalispell. Didn't have any alternates. The flight level we chose was 390. And our route. Go to Skyvector. We're going to take this right here up at the very top, copy it, and paste it in here. Estimated time of departure 0945 Z. Estimated time en route was 1 hour and 52 minutes. ETA was 11:37 Zulu, if I remember right. That's true airspeed, just put 400 in that box, nobody cares. Okay, 250 for our taxi fuel. Estimated route, en route burn was 63.44. Didn't have an alternate. Our reserve fuel is always 2,500. Didn't have any contingency fuel or whole fuel. Came out to 90, 90, or 90, 90, 90.
I feel like there was an in my heart.
9094. Okay, Minto fuel, we just take off the 250, and that gives us 88.44. For our departure airport, KSFO. Planned runway, 28 left, right. Outside air temperature 14. Planned winds. What were the winds in San Fran? 290 at 7. £75,000 for our planned max runway takeoff weight. Flaps 8. Planned takeoff weight of what did we end up for our final number on that? Going down to this sheet, it gives us a takeoff weight.
493.
Huh? Yeah, so this is our actual numbers, so this is the chart we're going to use. So our planned takeoff weight, 67,537. $67,537. Max V1 was that 128 knots we figured out already. Our planned destination, okay, is Bermuda. Our planned runway was runway 2. Outside air temperature was 9. Planned winds were
293 knots.
no, I think that one was variable at 3.
Yeah.
BRB 03. Just use the 67,000 pounds, flaps 45. Bless you.
Thanks.
And planned landing weight was 61,193. We didn't have any MELs. Our remarks is have a nice flight.
Thanks for all you do.
I was going to do that.
No.
Dispatcher signature. Yep. Pilot signature.
Oh.
ID 10T.
Oh, ha.
And we're good.
That's unreasonable.
Fun.
Okay, so everybody good?
Who's that?
Okay, there is a completed flight plan.
We did it.
Yay.
Every box filled out.
Well, it took us 3 hours.
Holy.
We talked a lot. Okay, so that being said, we're going to get this next one started, and I want you guys to work on it at home.
Can we take like a minute so?
Yeah, take a minute.